That was not here on Tuesday need a syllabus. Okay. So first of all, just a few announcements. I go through announcements at the beginning of class for the first 2 weeks, kind of remind you of deadlines and everything like that. After the first 2 weeks, you're on your own. You have the course syllabus. You should be able to read that. I mean, you're planning to be professionals or whatever. You don't need me reminding you what your deadlines are. Your course syllabus has all of those deadlines that are in there for you. First thing, always, when you come into class each day, I am, just like today, going to have questions that are available for you on the Socrative app. Sometimes they are survey questions. Sometimes they are a review of the previous class. Sometimes they are an introduction to the class we're doing for the day. So it'll vary. But they're always questions. You're going to be on your phone anyhow. And so I like to do this to kind of just get you thinking about chemistry before we actually begin each day. So I shouldn't have to tell you this every day. You come in, have your mobile device out, get into the Socrative app, answer those questions. As we mentioned on Tuesday, I don't formally take attendance in here, but your logging into the Socrative app with your chemical symbol is the way that I do, in a way, check to see whether you are here or not each day. So again, when you sign in, you don't sign in with your name. You sign in with that chemical symbol that you had from day one. And if you have not returned that card yet, I need yours back here. Make sure that you memorize that symbol that's on the other side. That is going to be how you will sign in with your name on the app each day. Next up, just some reminders. If we look at our syllabus, we have the extra credit practice problems that are due on Friday this week, and then some more on Tuesday of next week. We have the Mastering Chemistry homework quiz that's due on next Wednesday. The syllabus quiz email is due on Thursday of next week. The D2L portion of that syllabus quiz is due on Friday. And then we have an element quiz due on the 10th. Which element should we be learning for the element quiz? The shaded ones. And we need to know two things. They are, again, the symbol and the name. Those are the two things. The symbol must always have the proper case, and the name must have the correct spelling. Okay, so those two items. And we'll have some more details about that each day. Lab this week, you had your required safety training, even though I am not your lab professor. If you missed lab yesterday, you will need to complete that safety training before you participate in future lab activities. Your lab professor is Christopher Lutz, Professor Lutz. His contact information is in your course syllabus. We have safety training that runs in lab sections all throughout this week. So if you missed the lab yesterday, you will need to make sure that you get that safety training completed before you participate in future lab activities. It is a requirement of Minnesota State statute. So, and that has to be completed by even people like me. Even though I've had this many times over my teaching career, state law requires that I get trained on an annual basis as well. You do also need to have a lab notebook before you make it to lab. It should be a bound lab notebook, not a spiral notebook. Professor Lutz should have spoken about that as well. So those are the announcements. Any questions that anybody came up with on the course syllabus? Any questions? Okay, next, mastering chemistry or e-text issues or questions. I know there's some, but anything you want to ask before I tell you what I should be? How many are having issues still? Or put it this way, how many got into mastering in the e-text successfully? How many, did you all get an access code too? It worked? Wow, that's cool. I didn't know that. We were having issues up till Tuesday. In fact, there was a couple people that saw me and they had mixed some classes up. Those that spoke to me about access code issues, did you get in then eventually using the access code you were provided?
Different one.
A different one. Okay, good. Hey, I'm smiling now. That's cool. All right. So any other questions or anything about the syllabus or Mastering Chemistry, e-text, blah, 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 life? Okay. Let's look at the Socrative app quiz that you had coming in. We had several targets on there. Those targets looked like this, and your questions were to use words to describe them, either accurate or precise. So let's see how we did. And again, if you didn't come in and participate, you will not be getting, I will not be looking. To me, you are absent for today. So remember, you need to participate in these, and if you don't have a mobile device to participate, you need to talk to me so I know that you are present to class each day. All right, the shots at this target are, these are precise and accurate. Before we talk about what precise and accurate is, these are both precise and accurate. Next one. The shots at this target are neither precise nor accurate. And if we go on to the next one, shots at this target are good. Looks like those that answered, these are precise but not accurate. So if we had to, before we look at the next one, talk about the difference between precision and accuracy. What does precision mean? If we're looking at this one, what does it mean if we're precise?
It's all in one area.
Kind of all in one area. And if we're talking about numbers, what would that mean?
It's close to the same.
Right, it means that you repeated them very well. So we talk about the precision of a measurement or set of measurements. We're talking about their reproducibility. So things that are precise are very reproducible. What does it mean if something is accurate? Because according to this, these aren't accurate. What would they have to be accurate? Well, what was the answer to the first one? Where were they in order to be accurate? In the center, in the target. So we're talking about numbers. What would it mean if numbers are accurate? Rather than precise. Because we said precise. Precision was their reproducibility. What would it mean if they're accurate? Okay, turn to a neighbor and see if you can come up with something. I'll give you 30 seconds, very quickly. All right, let's wrap it up. Go ahead. What does it mean if we are accurate? We need 30 more seconds? All right, take 30 more seconds. Figure out what it means to be accurate. What does it mean? Okay, let's come back. What does it mean if we're accurate?
The numbers are correct.
Exactly, it means that the numbers are correct. So I'd use the example maybe like my scale at home, all right? And so one of the things I like to do each year is I like to write down my weight, and I like to go back and review my notes. The news is good this year, all right? And so when I step on my bathroom scale in the morning here today, I came up with this. I came up with 218 pounds, stepped off, stepped on again, came up with 217 pounds. Oops, I shouldn't be putting an S on there. That's actually when you abbreviate pounds. Even if you say pounds, it's simply LB. If I step on it a third time, maybe it shows 219 pounds. And yes, this to me is good news because I checked my notes last year, it was over 220. All right? So if I look at this, we could say that these numbers are reproducible. And they're reproducible within a range of how much? With 1 pound, sure. Plus or minus 1 pound. If I were to look at these numbers and wanted to express my weight, what would probably be the best way to express my weight? looking at this set of measurements I just did this morning?
217.
And why 217?
Average.
Okay, is that the average?
General center, I guess.
What is the average? 218 in the set, right? So probably the best way for me to represent my weight would be as 218 pounds, and I could say that my scale, well, you know, it's reproducible within a range of plus or minus 1 pound. That would be the precision of my scale. And so I'd be pretty satisfied with this, unless perhaps maybe I go to the doctor and step on the scale in there, and the scale says 225 pounds. All right? So I go to my home scale, 217, I go to the doctor, it says 225. Now, if I was a betting person, gambling person, the one that I'd probably gamble on being correct is probably the one at the doctor's office. So while my bathroom scale was very reproducible, it looks like it probably wasn't very accurate. Right. And so in order for it to be accurate, not only should my bathroom scale at home be reproducible, but it should probably also match the one that I find at the doctor's office. Okay? And so that's the difference between accuracy and precision. Precision is its reproducibility. Accuracy is how close it lies to correct or true value. Now, the other thing that this thing does right here is that when we look at these values in here, these are referred to as uncertain digits. These are uncertain digits because we find some variability in this digit. And it leads to us to utilize a term which, if you had chemistry before, and you should have, it leads to the use of this word, which we'll be using a lot in this course, and if you take it the second semester in there as well, it is the term significant figures. And we define significant figures like this. We say that significant figures are all of the certain digits in a measurement plus one uncertain digit. So it's all of the certain digits in a measurement plus one digit that is uncertain. And so if I look at this particular measurement, it doesn't matter whether I look at the 218, 217, or 219, based on this definition, how many significant figures would we say that each of these measurements has? 3. And it has 3 because these are the certain ones, plus we have this one where we have the variability, which would be the uncertain digit. Exactly. So we would say that these measurements have 3 significant figures. So that takes us now, and don't yell these out, I have 2 graduated cylinders here. I'd like for you to look at the volumes on these graduated cylinders. I'm going to blow these up a bit. Well, not that much. But I'm also going to put these on your Socrative app. Oh, well, we didn't finish that. That's okay. Let's go then and pull up another quiz here on your Socrative app. And this one has your volume on there, so you should be able to see it nice up and close on your screen. So if we want to show this with the correct number of significant figures, what number would we write in here? Now, if you don't yet have that Socrative app, you should be having it downloaded and participating with us, please. Again, it's the Socrative Student app. And while you're waiting, I'm showing the other one that you'll be doing. This will be the second one that's going to show up on the Socrative app, right here. Yes?
What is the code?
The room is always, help us out, what is it?
Chem Lancer.
Chem Lancer. Chem Lancer. Remember, when you sign in with your name, you don't use your name. What do you use?
Your element.
Your element. That's right. Your chemical symbol. And you should always be discussing these. It's way too silent in here. If you're unsure, nobody likes to be wrong. Discuss with the neighbor what they are. Because you want to find your answer here amongst the right ones, not the wrong ones. Okay, we'll give you 15 seconds. Get an answer locked in, please. We'll count down. 5, 4, 3, 2, 1. Correct answer here. I see a number of them. The correct one is going to be 23.5, or you could put 23.6. You might say 23.4, 23.7. Why would a 23.6 or 23.5, either one, be correct? Because the last digit is the uncertain digit. Now, if you went out and put 23.50, like one did here, you're actually putting in two digits after the decimal, and both of those digits will wind up being uncertain. And if you're putting 24 or putting 23, like there are a couple in here, those, of course, we know it's somewhere between 23 and 24. So if you said 23 or 24, you're not being as precise as you could be. So you will always try to estimate what that last digit is in the measurement. So again, if that last digit then is going to be an estimated digit, let's do the next one here and record your volume. See, I would have said 23.6 on that last one if I was doing it. But the last one's given me a good feeling. Give me a good feeling on this one here too. Okay, we'll give you about 15 seconds. Looks like we don't need that much. We'll count down here. 5, 4, 3, 2, 1. And 7.35 looks to be correct. 7.36 is what I would put. But 10.5, not quite sure where that one comes from. If we're somewhere between 7 and 8, we know it has to be between 7 and 8. This should be 7.1, 7.2, 7.3, 7.4. So it has to be between 7.3 and 7.4. Okay, any questions on these? Oh, you know, this makes me feel good. You might say, that's silly. These are easy. And they should be easy. Because, you know, a very common answer I get, well, this is a good one to point out, especially with intro students, I'll often see an answer of 20.3 or 20.4. And you might say, how in the world did they get that? Well, I see it a lot, and I didn't see that at all in here. And so that actually makes me feel pretty good. Okay, let's go on from here. Let's look at a couple other things. These are some areas where students have issues with significant figures. They are as they pertain to leading zeros and trailing zeros. Leading zeros and trailing zeros. Now, leading zeros, of course, are going to be the numbers that appear at the beginning of a number. Trailing zeros are the ones that appear at the end. What we say is that leading zeros are not significant. And for trailing zeros, we say that these are significant, but it has to have a qualifier. And that is when the number has a decimal, and we say that they may or may not be significant when the number has no decimal. I apologize for my sloppy writing, but I'm using a small stylus because my regular one here is not working. And so I'm not sure why it isn't. So with this in mind, and now I forget what I have next to my questions, but I have a couple numbers here that I'm going to write down. The numbers are 0.003 grams and 3.000 grams. Now, based on these two definitions, I don't think I have these on the Socratum, but based on these two definitions, how many significant figures would this first one have? It would have just one. This one here would have 4. Okay, because in each case, which digit is the uncertain digit? In this one here, which one is the uncertain digit? How many significant figures are there again? 1. Which digit is the uncertain one? The last one. Which digit is the uncertain digit in this one here?
0.
Which 0? The last one, exactly. Again, this one here has one significant figure, which us chemists like to call sig figs. So we say that this one here has 1 sig fig, and this one here we say has 4 sig figs. And in each case, we say that the uncertainty in these measurements is plus or minus 0.001 gram, telling us that this last digit is an uncertain digit. And so one of the things we ought to gather when we look at these here is this, and that is if we have a small number of significant figures, in fact, before I even say that, if I were to ask in which one of these two is this uncertainty or this precision, in which one of these two is this uncertainty a big deal? And in which one of these two measurements is this uncertainty not a very big deal? So let's start with the big deal. Which one of these two is this a big deal? First one, exactly. And why is this such a big deal in the first one? It would change what? Yeah, it changes the value again quite a bit. And when you say quite a bit, doesn't it change this one by the same amount?
Yes, but not always exposed.
Right. It has to do with relative amount. So relatively speaking, in this case, it's a big deal because this uncertainty is 1/3 the size of the measurement. Okay, in this case, though, this uncertainty is only 1/3000th the size of the measurement. And because this is a 1/3 error, a 1/3 error is a huge error. It'd be just like if we gave you an exam and I said, well, your score is 60 plus or minus 20. Okay? That's a wide range. You're not going to be happy with that. Okay? So when you have a small number of significant figures, like this is, that means that you have a relatively large error. And when you have a larger number of significant figures like this, that means that your error, relatively speaking, is very small. And so that's how you're supposed to interpret significant figures. When there's a very few number of significant figures, it means a relatively large error. When there's more significant figures, that means a relatively small error. And one of the ways that you can kind of show that is if we express this in some different units. For example, if we looked at this first one and instead of expressing it in grams, expressed it in milligrams, it'd be very clear that we look at something like a measurement of 3 milligrams, that this one here has just one significant figure. So when we talk about measurements here in chemistry and the other sciences, not only are we looking at the concept of decimal places, but the term significant figures becomes important as well because it helps us give an idea of what the relative error is in a measurement. Now, in order to describe this one right here, we might use an example like this. We might use something like 3,000 kilometers. So if we're talking about the distance, say, from here to San Francisco is 3,000 kilometers. Well, when you look at this measurement now, this one has no decimal place in it, and so what we don't know is whether these trailing zeros are or are not significant. we don't know whether this is the uncertain digit, this is the uncertain digit, this is the uncertain digit, or this is the uncertain digit. If I pull this number off the top of my head, because I've been to San Francisco a few times and said, well, it's 3,000 kilometers from here to San Francisco, well, I know for sure that I'm good out to the nearest 1,000 on that. I know that. And because I've been there a few times, I also know that it's about 1,600 miles. I know the conversion in my head. And because I know the miles to about two significant figures, I'm actually pretty confident that this is good out to the nearest 100. And if it's good out to the nearest 100, then it would have two significant figures. But if we actually measured the distance and we came up to the nearest mile, being 3,000 kilometers, then we could say that this measurement has a total of 4 significant figures. And simply by you looking at it, me writing it like this, there's no way for you to know. So what is a one way, and if you had chemistry or physics before, you should know how to do this. What would be one way to clarify the number of significant figures in this measurement if you wrote it out? How do you think I could write this with 2 significant figures? Scientific notation, sure. And if I wanted to show this with 2 significant figures in scientific notation, how would I do that? Go ahead, Zachary.
3.00 or 3.
What should I put?
3.0
Okay. Then what?
times 10 to the 4th.
Times 10 to the
4th? No, 3rd.
third. There you go. Yep. Kilometers. And now if you write it like this number now has a decimal place in it. And now with the decimal place in it, this would have 2 significant figures. So if we wanted to write this out to the nearest 100, that is good out to 3 significant figures, how to write it out to 3 significant figures? Right, 3.00 times 10 to the 3rd kilometers. So again, this one here would be 2 sig figs. This last one here would be 3 sig figs. Okay, let's go ahead and, first of all, any questions on these? So if we're unsure, if we cannot, if the number of significant figures is unclear, in order for us to clarify those significant figures, we should write them in scientific notation. So with that said, let's go ahead and see. I have some numbers here. I'm going to write them down. They are 60.0500 meters. We'll have 0.00326 kilograms. We have 246.3 milliliters. And we have 3.5 times 10 to the 12th kilometers. Tell how many significant figures are in each of these measurements. And each of these will come up in order in your Socrative app. But before we do them all, let's figure out, discuss with the neighbor. I'll give you 2 minutes here. Discuss with the neighbor how many significant figures are in each one of these. So once we get to them on the Socrative app, we'll go boom, 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 boom. Go ahead.
I remember that. So it's because it's equal trailing 0.
Okay, the first one is up on the Socrative app right now. Let's go ahead and get your answers locked in, please. Okay, we're going to count down. 5, 4, 3, 2, 1. There are 6 significant figures. Which digit is the uncertain digit in this one? The last zero. The uncertain digit is always which one? Always the last one. Good. Get this one in here, please. How many sig figs are there in 0.00326 kilograms? Okay, we'll get our answers locked in. We'll count down. 5, 4, 3, 2, 1. Great. This one has 3 sig figs. Where do we start counting on this one? At the 3. So we count the 3, 2, and the 6 as significant figures. Next up, how many significant figures are in 246.3 milliliters? Let's get our answers locked in, please. We'll count down. 5, 4, 3, 2, 1. There are 4 significant figures in this one. And then our last one in this set, how many are there in 3.5 times 10 to the 12th kilometers? And we'll get our answers locked in, please. We'll count down. 5, 4, 3, 2, 1. And of course, there are 2. And we get that. Remember, even though it's in scientific notation, we simply look at these digits right here and we see 1, 2. And this would have 2 significant figures. Any questions on these? All right, next up. Now, I understand this is a review, and it should be a review because, again, chemistry is a prereq in here, and you should have had some algebra, but it's always good just so we're all on the same page. You are going to be expected to write numbers out in scientific notation correctly. So if we had a number like 15,200, and we wanted to write this in scientific notation, tell me, how many places should I move the decimal here? Tell me when to stop.
Stop.
Right there. And why did I stop here? Because the number should always be between 1 and 10. So to write this as 1.52, then I'm going to go times 10 raised to the power of 4. How about negative 4? No, it's positive 4. Okay? Now, before I tell you my strategy, we'll look at one more. I'm going to write this out as point, and I'm going to count zeros here now. I'll put in 1, 2, 3, 4, 5, 6, 7, 8 zeros, and then a 4, 3. So 8 zeros after the decimal, and then a 4, 3. So if now I want to write this out in scientific notation, I'm going to move it 1, 2, 3, 4. Tell me when to stop. I've moved 4 now. 5, 6, 7, 8, 9. Right there. Okay. And why am I stopping here?
Because it's in between 1 and 10.
Between 1 and 10, exactly. So I'm going to write the number 4.3. And this now will be times 10 raised to the power of negative 9. Okay, now, believe it or not, I was a really good student. I mean, really good. The one subject I got A's in my entire life has been math, okay? But the one thing I never got in math was scientific notation until I was probably in about my second year of college. I always got it mixed up, and that's because I learned it the wrong way. Now, when I learned it, maybe this is the way you learn it now too, and if you're learning it the wrong way. How many learn it by counting to the left and to the right? You learn it that way? See, in my opinion, that's the wrong way, because I got confused, and the reason why I got confused is if I saw a number like 1.52 times 10 to the 4th, I learned that when you move the decimal place to the left, it's a positive exponent. And so I would look at this and I said, oh, well, this is a positive exponent. I move it to the left, 1, 2, 3, 4, and then I'd get this number in there, and what do you think I'd find out? Yeah, I'd get that thing wrong. So here's the way I think is the right way to learn it. And that is, really big numbers are always going to have exponents that are positive, really little numbers are going to be ones that have negative numbers. And so if you learn it that way, and it should make sense, really big is positive, really little is negative. If you learn it that way, then I'd come back to a number like this, and I'm not worried about moving left or right. What I'm looking at is I'm saying, oh, this has a positive exponent, so this must be really big. And if it's really big, then I'm going to move the decimal in the direction that makes this a really big number. Okay, and so you don't think about it as left or right, you think about it as really big or really small. So with that in mind, let's go ahead, and I have a couple up here on the Socrative app. Let's go ahead and check these out. And again, I always encourage you to discuss with a neighbor before submitting. Okay, get your answers locked in, please. And the first one here. Wonderful. Nice job. Next one. This should be a familiar number. 92,300,000. If you're a geek like I was. Anybody know what this number is? Yes! It is the average distance to the sun in which units?
I have no idea.
Miles. Miles. How about that? Wow, I'm impressed. Very good. Another fellow geek. Yeah, how about that? Nice job. All right, so next up, any questions on either of these? We shouldn't. You got 100%. So let's look at the next one here. We're going to look at the word exact. Now it turns out that not all measurements have uncertainty in them. In some cases they might be exact. When we say that a measurement is exact, what that means is it has an infinite number of significant figures. Okay? Now, examples of something that could be exact. I have how many fingers on my hand? 5. I don't have 4.9, I don't have 5.1, I have 5 fingers. That has no uncertainty. If it has no uncertainty, that means it has an infinite number of significant figures. The number 5 in that case won't have one significant figure, it would have an infinite number of significant figures. Because I have exactly 5.00000 on into infinity fingers on this hand. Okay? So, counted items have the capability of being exact and having no uncertainty. So, counted items are one thing. Another thing that can have be exact is defined quantities. So if you look and pull out your conversion sheet from your syllabus here the other day, you're going to notice that there's some conversions on there. Some of these conversions, the ones on the top section there, these are English to metric conversions. Your English to metric conversions, these are good out to 4 significant figures. But if you look at your English to English conversions, these conversions here are exact. And again, if we say that these are exact, it means they have how many significant figures? An infinite number of significant figures. Okay, but your English to metric, because there's 2 different systems, these here have been given to you out to 4 significant figures. Now, some conversions you won't find on here are your metric to metric conversions. It turns out that you are going to be responsible for learning metric to metric conversions. We'll talk about that a bit later here today. But the metric to metric conversions that we learn, those are also going to be exact conversions. Okay, now where this whole thing in significant figures comes into play is when it comes to calculations. And up here, now sometimes people, what the heck, there's a camera up there, okay, just if you're wondering what's going on here. And so I'll bring in things to demo on the bench here. I have just a card like this, an index card that I have written out some measurements onto, and I've measured the length and I've measured the width of this card. And I want to find what the area is of this particular card. So, what I'm going to do here, let's see, where are my notes? Here we go. I'm going to write down the length. I'm going to write down the width. And of course you can't see this. So we'll bring that back up here. And I have a length of 13 point, what do we say, 96? And we have a width of 10.77 centimeters. Now, go ahead and calculate the area. Now, if you didn't bring with a calculator today, you may borrow one from me, but I need some collateral. You don't have any collateral? I'll take your pen. I'll take your phone. Do you have anything else to write with?
Yeah.
Do you? Great. Grab one. Anybody else need one? I need some collateral. Great. I am thirsty. All right. Anybody else need? All right. I'll take some collateral. Pencil. Is that important to you? Kinda. All right. Anybody else need? Okay, I need some collateral. You can give me whatever you want. Something that's important to you. I'll take your phone. Oh, you need that for Strata. Give me something else. Anything? Anything in your hand? I'll take your pen cap. All right. Take a calculator. Anybody else need one? All right. Let's go ahead and calculate the area of this. And if you want your collateral back, I need the calculators back after class. Sometimes people give me their shoes. Okay. So let's see, doing this now, 13.96 times 0.77. Looks like I get 209.72. Now, what are the units on this measurement? Oh, is that right? No. What's wrong with that? I think my calculator missed a button here. Let's try again. 13.96 times 10.77. There we go. That looks right. This looks better. How about 150.3492? Okay. Now, before we talk about how we round these, let's say that I were to repeat this measurement. Now, if I were to repeat this measurement, which digit in this first one is the uncertain digit? The 6. So if the 6 is uncertain and I repeated it, maybe the next time I get 13.95 centimeters. And which digit is the uncertain one in this one? The last 7. So maybe the next time I get 10.76 centimeters. I repeat it again and maybe you get 13.97 centimeters by 10.78 centimeters. And so now if I were to calculate the area in each one of these, we'll go through 13.95 times 10.76. I think my 0 button's not working. There we go. I get 150.102 square centimeters. And if I do it again, I have 13.97 times 10.78. Looks like we get 150.5966 square centimeters. All right, now I want to round these numbers off. To which digit after the decimal or before the decimal should each of these values be rounded? Should I round them to the nearest 10,000th? How about the nearest 1,000th? How about the nearest 100th? Nearest hundred sound good? What else would it be? Nearest tenth? Okay. Now, if we went back to our definition for significant figures, the definition for significant figures said that the significant figures are all of the certain digits in the measurement plus one digit that is uncertain. And so if I look at this here, which digit, let's start with this place, is the hundreds place uncertain?
No.
Is the tens place uncertain? Is the ones place uncertain? Is the tenths place uncertain?
Yes.
Yeah, we see now that there's some variation in here. And so because that's where we see the uncertainty, that's where we should be rounding these values off, is to the nearest tenth. And so this first one should be rounded off to 150 point. How much? 3. The next one to 150 point 1, and the last one to 150.6. And now when you look at these, we can see that all of these digits are certain, plus the one digit here that is uncertain. And so with that, we wind up with some rules for rounding that look like this. When we have multiplication and division, the rounding rules look like this. We say that the answer should be rounded. Answer should be rounded. So it has the same number of significant figures, which I'll abbreviate as sig figs, as the measurement having the fewest sig figs. And so if we went back to that and looked at our values here and see how we applied this, let's just look at the last row here. How many significant figures did 13.97 have? How many significant figures is 13.97? 4. How many significant figures is 10.78? 4. So the fewest between 4 and 4 is 4, which means our answer should have 4 significant figures. And that's how we determine it. We do not determine it based on decimal places. We determine it based on significant figures. And if we weren't multiplying and dividing, let's say instead that we were doing this. I'm going to try to paste this. There we go. Now I'm going to go through and change this from multiplication and division to addition and subtraction. Now the rule isn't going to be the same. We have to change some words in the rule. Any idea which word or words we need to change here?
Number of sig figs.
Okay, and what are we going to change that to?
The decimal place.
Exactly. So it is identical in definition, except we are going to change this to read number of decimal places. And so if you came in here thinking that we should have rounded based on decimal places, that would have been correct if we were talking about addition or subtraction. But when we deal with multiplication and division, the rounding rule is based on decimal places. So with that in mind, I don't recall if I have any Socrative app questions on there. I don't. Okay, so let's go ahead and look at this example then. Let's have us add together some numbers. Let's take 25.36 liters, 1.2 liters, and 634.1 1 liters. And let's sum these together. Six. So it looks like we have 660.66. But based on our rounding rules, this means we should round this answer to be 660.7 with a label of liters. Exactly. Okay, let's try these out on the Socrative app. Provide the answer with the correct number of significant figures. Now think back to your rules. What operations are we doing? And I would always run my answer by a neighbor before submitting because I hate being wrong. So run your answers by a neighbor. This is going to be the next one on the Socrative app if you have it completed. And this is going to be the third one on the Socrative app. I forget what units I'm in on that one. Let me check real quick. Oh, maybe I forgot to put it in. All right. So let's check out the answers on this one. We'll count down. 5, 4, 3, 2, 1. 5.15. That's because your answer should have how many significant figures? 3. The numerator up here has how many sig figs? 6. The denominator has 3. The fewest of 6 and 3 is 3. So our answer should have 3 significant figures. Next one here. Answer this one with the correct number of decimal places. If you get done with that one, you can calculate the area of this box with the correct number of significant figures. What is the area with the correct number of significant figures? I forgot to get this one on the Socrative app, but a box measures 44 meters by 43 meters. What is its area with the correct sig figs? So I'm going to give you about another minute here to both to get this answer in and to get an answer for this area with correct sig figs. Okay, about 30 more seconds to do these two with correct sig figs. Okay, let's go over the answer to the first one. This one here, the correct answer is 267.3 kilograms. Because this one here, the operation now is what?
Smallest decimal. Or
Smallest decimal place. What is the operation?
subtraction.
Subtraction. If we subtract, we don't look at significant figures, rather we look at decimal places. The fewest decimal places in here is 1, which means our answer should have 1 decimal place. Okay, now I forgot to put this one on the Socrative app. How about an area? What do we come up with for the area with correct sig figs? Anybody care to give this one a shot? Yes, go ahead.
It's 1,800.
1,800.
800
Okay. And the units would be?
meters squared.
Meters squared. Okay, anybody have a different answer? What do you have?
1,900
1,900. What are the units?
meters squared.
Anybody have a different answer? Yes, what do you have?
1.9 times 10 meters squared.
Okay, anybody have another answer? The correct answer is up here. Which of these three do you think we ought to go with? Why the last one? Are you knowing now?
Yeah.
Yeah, because you rounded wrong, right?
Yeah. I didn't round at all.
Yeah. Okay, so you came up with 1,800, I forget what it is, 1,892.
92.
Okay, so if you have 1,892 square meters, of course that rounds off to 1,900, and that's okay. We forget that happens. 1,900 would be okay, except for what's wrong with this?
Decimal.
No decimal, right? So we don't know whether these trailing zeros are significant or not. So that means we have to express it in units of, or not in units of, but in scientific notation. Okay, and that's not so much in this class. I still answered in this class, but especially in my intro classes. Students will look at answers on the back of the book on Mastering Chemistry, and they'll want to know, why is this one in scientific notation? Well, it's in scientific notation whenever we want to clarify the precision of the measurement. That is, we want to clarify the number of sig figs. Okay? So we're going to move on from here. Any questions on these? Yes?
Wait, so for 1,900,
Yes.
why couldn't you just like ignore the 2 zeros and say that the 1 and 9 are significant?
Well, for one, there's no decimal, so without you telling that to me, I don't know whether the 9 is the uncertain digit, this 0 is uncertain, or this one is 0. And that's why we have the rule that says when we have trailing zeros, if there's no decimal, those trailing zeros may or may not be significant. There's no way, unless you told me this is good to the nearest 100. So if I don't want you to tell me, or if you're just going to put it down so other people know that it's good to the nearest 100, then by default we put it into scientific notation. Okay? Good question. Anybody else? Okay, now, scientific calculators. Let's pull them out. We're going to look at these buttons. Now, many students come into here thinking they know how to do scientific notation on their calculators. We find out that most students actually don't know how to do scientific notation on their calculators. So, what you need to do is you need to find one of these 3 buttons. You need to find the EE button, the EXP button, or a button that says times 10 to the Y or times 10 to the X or something like that. Not the 10 to the X button. So if you're using the 10 to the X button or 10 to the Y button, whatever it is, you should not be using this one right here. If you are, you're using something called an anti-log feature, and you risk the chance of getting wrong answers. The second button you'll need to find on there is either the negative button, a plus/minus button, or one that's a plus/minus kind of with swapping arrows like this. Now if you have a TI, well, if you borrowed my calculator, you're going to see the EE above the X for the -1 key, which means in order to access it, you need to do a second function. If you have a TI 83 or 84 calculator, your EE is located above your comma. So you'll have to use a second function to access it. So find these two buttons. Anybody need help finding those buttons on your calculator? Need help finding yours? Okay. Right there. Yeah. Anybody else? All right. So now, if we want to enter a number in scientific notation, let's say we want to put the number 6.022 times 10 to the 23rd into our calculators. We want to enter this into our calculators. Now, it's quite simple. We put it in 6.022, and then we hit the EE button, and then 23. And that's it. You don't put in a times, you don't put in a times 10 raised or anything. Simply entering it like this is entering this number in scientific notation. This button right here on this first row stands for times 10 raised to a power of. That's what these buttons in the first row mean. And a very common mistake I see students do in here is I'll see like a 6.022 times E23. If you try that, you're going to see your calculator shows up displaying 6.022 times 10 to the 24th. Okay, so it's just a simple EE button. And if you wanted to put in something like 4.8 times 10 to the negative 17th, then you'd put in 4.8, you'd hit that EE button, and then your sign changing button, 17. And that's it. Now if you have a different model calculator like a TI-35, yours is a little bit different. But these are the ways that these things are put in. So what I'm going to do is, if you have learned this now, I'm going to have you do these next two calculations, and these will show up on the Socrative app. Let's do 4.4 times 10 to the 22nd divided by 6.6 times 10 to the negative 33rd equals, and then let's also calculate the answer to 3 times 8 over 5 times 11. So we're going to do these two on your Socrative app, using what you just learned now about entering in your values. So your first one there is up on the Socrative app right now. Before you commit yourself, please run your answers by neighbors. I don't just say that just to say it. It's because some of you will have mistakes, and don't enter in a mistake if you don't know how to do it. Somebody that does know how to do it will help you. Okay? So talk your answers over before you submit them. Talk your answers over before you submit them.
So it'll be 6, 7.
The second one that you'll be doing is also written up here. This is the second one you'll be doing. With the next one, it'll show up on the Socrative app. But get your first one entered, work on the second one. I'll give you 30 more seconds on the first one. 30 more seconds on the first one. Okay, let's get our answers locked in, please. We'll count down. 5, 4, 3, 2, 1. Hey, I love this. I'm going to love this semester. Thank you. Thank you. I didn't sleep well last night. I'll sleep well tonight. All right, let's do this one. Now this one here, all of these numbers I'm telling you are exact, and because they're exact, I want you to express this answer out to 3 decimal places. Express this answer out to 3 decimal places. Remember to run your answers by a neighbor before you submit. Okay, I'll give you 15 more seconds. And we're going to count down. 5, 4, 3, 2, 1. Correct answer is 0.436. You could also write it as 0.436. You could write it as 4.36 times 10 to the negative first. All of these answers up here are correct, with the exception of this first one. It is not 4.36 times 10 to the 10th. Okay? Any questions on these? Okay, here's where we're going to wrap up for today. For today, I have some things that you ought to know. First of all, we have 2 tables. If you've looked at the e-text ahead, they do not have traditional page numbers like I'll talk with the 3 of you guys after class today, all right? Is that cool? Yeah, thank you. So hang around here for just a bit. In chapter 1, we have a couple tables that I expect you to know a few things. First of all, this one here are things we're going to be covering in 1061, and these here are things we'll cover in 1062. These are examples of what we refer to as base units. And there are 7 different categories or 7 different types of base units that we use in this class. And when you look through these, sometimes students are surprised to see that the base unit of mass is not the gram, but rather it is the kilogram. And when you look at the temperature, surprised to learn that the base unit is not the degrees Celsius, but rather kelvins. So when we talk about expressing things in SI units, which SI comes from a French abbreviation which stands for the International System of Units. These here are examples of SI units, of which these are the base units. When we talk about base units are something that are used to describe all of the other units that we'll be working with these 2 semesters. Any types of measurements we make can be made in these base units or some combination thereof. And sometimes when you look at this, you might say, well, now one of the things that seems to be missing up here is a liter. Okay, because you're looking through and don't see liter under any one of these. And that's because liter, it turns out, is an example of what we refer to as a derived unit. It's still an SI. It's still a type of SI unit that we're using, but it's an example of what we call a derived unit. And a derived unit is one that is derived from a base unit. Now, up here, I have 1 liter. This represents 1 liter. And if I were to look at and go back to these base units in here, you'll see that the meter is a base unit of length. Turns out that if I had a box that measured 1 meter, and so now if you I'm not a good artist, but I can draw cubes. So if you ever want to draw a cube, basically you draw a couple squares that are offset from each other and then join these sides together. And now if I had a box that measures 1 meter by 1 meter by 1 meter, and you can measure now, think of this now, 1 meter by 1 meter by 1 meter, that is going to be a very big box. And if I were to calculate the volume of this box, what would the volume of this box be? What is the volume of this box?
1 meter cubed.
1 meter cubed. And it turns out that this 1 meter cubed is the SI unit of volume. Problem is that this SI unit of volume is a huge volume. So we needed to come up with something that was a little bit more convenient to work with. So that's something that's a little bit more convenient to work with is, instead of it being 1 meter, if you're looking at this, this is actually 1/10 of a meter by 1/10 of a meter by 1/10 of a meter. And so instead of this being, again, 1 meter by 1 meter by 1 meter, this box that you see up here measures 1 decimeter by 1 decimeter by 1 decimeter. Meaning that this box, instead of having a volume of 1 cubic meter, has a volume of 1 cubic decimeter. That's what the volume of this box is. And turns out that this volume right here is also the same as, I'm trying to find my eraser, here we go, is also the same as 1 liter. So as you memorize conversions in here, this is conversion number 1 you need to memorize. 1 liter and 1 cubic decimeter are the same thing. Now, we don't use decimeter a whole lot to measure things in here, so instead of a decimeter, we'll use centimeters. This measures 10 centimeters by 10 centimeters by 10 centimeters. And so if we put this in instead as 10 centimeters by 10 centimeters by 10 centimeters, another volume that we could use to express the volume of this box would be how much?
Centimeters
Right. So this is also 1,000 cubic centimeters. Now, in fact, if you went in here and looked at it in this box here, this is made up so that if I take these out, each one of these little things that's in here represents 1 cubic centimeter. And it turns out that there's 1,000 of these little cubes that will fit into this large box. Now, there's also 1,000 of something else that will fit into this box. And the 1,000 of something else that fits into this 1 liter box is 1,000 milliliters. 1,000 milliliters. So if it's 1,000 milliliters, how do I get rid of this? I don't know. So it's 1,000 milliliters. I can't get rid of that right now, but there's 1,000 milliliters that are in here. And so if there's 1,000 cubic centimeters that are in here and 1,000 milliliters that's in here, that means that 1 cubic centimeter and 1 milliliter are the same thing. Now, what's interesting about that here is this. I don't know if I still have them on my cart. I usually carry them around, and I don't have them all here right now. But if I look at this, this is an older syringe. All right, and here is, yeah, this is also an older syringe. If I look at this older syringe, you maybe can't see that from here, but you'll see that it has a label on here of cc's. cc stands for cubic centimeters. If you go to the doctor's office today, you're not going to see them labeled in cc's. You're going to see them labeled in milliliters. And the reason why that came about, this happened probably about 25 or 30 years ago. What happened is, it turns out that there was a number of calculation errors that took place when it came to dosages. So it turns out that the prefix centa means 1/100th. So if you have 1/100th of a meter, that is 1 centimeter. And people often got that confused when they did with volume measurements, in which there are 1,000 cubic centimeters in 1 liter. So today, Again, if you go to the doctor's office, they measure everything in units of milliliters. So we avoid that confusion that might take place of the prefix centa with how it's used in cubic centimeters. So, looks like we've used up the time today. I have some more questions on the Stratabat, but we're going to have to skip them. Any questions that you have? Yes?
Are we able to write on this, or do you not want us to?
You can write on the periodic table and conversion sheet all you want in here, but when it comes to the exam time, you're going to get a clean copy of the periodic table and
So we're
conversion
not using
sheet.
this exact one?
You're not using, you'll get that exact one,
But not this specific?
but it'll be blank.
Gotcha.
Yes.
I always had a question, are the TIA good for the final test? Or do we have to
Not
do
for the final.
Okay, but
Yeah.
every other test?
Every other test, yes. All right, guys, thank you so much.